Hello guys, hello, welcome back, and this is me with Trevor with Explaining Your Code. And today we're going to be talking about insertion sort. Now, basically what I get about insertion sort is that it's another simple but inefficient, what I mean to say, efficient sorting algorithm. The first iteration of this algorithm takes the second element in the array, and if it's less than the first element, it swaps with the first element. The second iteration looks at the third element and inserts it into the correct position with respect to the first two elements. So all three of the elements in order for added its iteration of this algorithm, the first elements in the original array will be sorted. Okay, so this is basically what I understand about the insertion sort. As you see, we've been in this series, we're going through what is sorting. We did bubble sorting, we did merge sorting, and now we're doing insertion sort. Okay, let's move on. Insertion sorts at its iteration, it inserts I plus 1 element into the correct position with respect to the first I elements after the iteration. The first I element are sorted requires a worst case of n square inner loop iterations and outer loops iterations n negative 1 times. Inner loops requires n minus 1 iterations in worst case. For determining big O, nested elements means to multiply the number of iterations has the big O n square notation. Alright, so this is the main body of the code here. So as we see in the integer insert, what that's actually doing is holding the element to the insert to be inserted while the order elements are moved. So basically that's a temporary variable to hold the element to insert. So it's something temporary to hold it. Then again, we look down in something to the 4 there on line 43 to 46. What's that basically doing is it's iterating through the negative 1 items in the array, and then it keeps track of where to insert the element. So after it keeps track of it, then it initialize a location to place the elements. After it finds where to place it, then it stores it to the value of the element that will be inserted in the sorted portion of the array. Then after that, it search for a place to put the current element. After it searches, it's going to do a loop sequence to locate the current position to insert the element. After that, it's going to shift the element right one slot. So it's going to move an element to the right, and not only move it to the right, but it's going to decrement the position at which to insert the next element. Alright, let's see the raw code, the one we're going to be compiling. Where is it? Let's find it. That is insertion. Okay, here we go. As you see on top here, the basic prototypes. And then we have the declarations of the array that will be sorted. And then basically here's what we just explained. And then yes. So I'm gonna go through this really quick again. So this is the temporary variable, the initiate the location, search for the location, then it places the insert algorithm, then it indicates the swap, it finished the arrays, and then it indicates the amount of arrays that is sorted, then adds a new line, then it gives me the number of loops and the number of swaps for each view. Okay, let's compile this thing, hope it works. Right, bash. Oh, this one is from the last one. Let's hit clear. Then let's do Sort. Okay. Okay, give me a second here. Okay, it's up to date. So we have the unsorted array. Then the after pass at this point it's 1 0 0 0 0 0 0 1 3 3 8. Then the after pass again. This is the first. Okay, this is the first after pass, second after pass, third after pass, fourth after pass, fifth, sixth, seventh, eighth, ninth. And then it tells me the abort trap was sixth. And then you notice how each one has amount of swaps and the general amount of loops that it did for each one. Okay, guys, this is the most I can do with this code of in explanation. See you next time, and have a nice one. Bye bye.